Q&A session. And again, that is Option Y on Mac or Alt Y on Windows to raise your hand. Anybody who has questions? And, there we go. Mr. Alec, go for it, sir.
Yeah, Tim, can you hear me?
Yeah.
Okay, Pepe, good seeing you again.
Yeah, good to see you too.
I see you made the big leap into the quagmire here like the rest of us.
Yeah, I finally decided to do it. Thank you.
Yes. Okay, well, you know, the one area of research that really fascinates me is the Stanley Myers water car. And I had the privilege a few years ago of seeing a demonstration of an engine that actually, it ran on water. I mean, the thing was for real. And the guy working on it took it to China. But I haven't heard from him since.
Oh.
But apparently it's real technology. It runs on what's called Brown's gas, which is an area of interest that I have in. And his patents, if you dive into his patents, he dives into opposing field action. Okay, it could be magnetic, electric, but you have to set up these opposing fields to get at the scalar function. Okay, and that's what Tom Bearden spoke about. And hopefully Tim will let me give a talk here later on today. If not today, maybe some other time here on Tom Bearden's technology. And you know, again, this stuff is for real. Cavitation, I think, also produces a Brown's gas as well. And so a lot of these other researchers have looked into it. It also leads to transmutation of elements as well. So very interesting research, you know, in that area. So yeah, welcome to the quagmire. You'll never leave.
Yeah, I know.
You're in it for life.
Yeah, I know.
Life for like the rest of us here.
Yeah, thank you. Good to see you too.
Wonderful. Okay, so there's that. Let me see. That was Bill. So who else? Again, it's Option Y on Mac or Alt Y on Windows. I have memorized the Zoom question things finally after all these years. Okay. Oops. And somebody new entering the room. Yeah, and I'll just, again, anybody who has questions, that's Option Y on Mac or Alt Y on Windows. And again, Pepe, thank you so much for presenting. It was wonderful to have you share all of that. And that was very in-depth. You guys today, again, we've got the fire back in this conference, you know?
Yeah. Yeah, no problem. Thank you. Thank you for letting me, well, share my ideas. And hopefully it helps other people too.
Yeah, no, I think it absolutely does. I think it helps them kind of identify, okay, you know, I mean, if they have a device, if they have a design that they're working on, it helps them kind of take a high level view and say, is this on the right track? Or, you know, are there things that I'm missing? And then I think it also helps people look for points of leverage, right? And, you know, one of the things, and this goes back to when I was doing American Anti-Gravity back in the day, but people used to talk to me about, you know, are you looking for this or that or the other thing in terms of physics? And I'd say, you know, I'm looking for leverage. That's what I'm looking for. I'm looking for ways to leverage energy and move energy around. You know, just being able to, I mean, in terms of pure physics and stuff, that's already established. I'm looking for the holes. I'm looking for those little, you know, that place where you can put something in and get something out that's not what you expect. So, yeah.
I believe the secret is in lower energy density bubbles, because that way you can control nature and you let nature do the work. You don't do the work. Nature does it.
That makes absolute sense. I saw that at the beginning of the presentation, and yeah, and you know, and the airplane wing is a perfect example, right? Where you're lowering the pressure, and then the surrounding atmosphere does the work. And in terms of energy, yeah, same thing, right? It's, you know, you could call it the Aether or the 0 point or whatever. I mean, the Casimir effect might be one example of that, you know. So let me go to Mr. Philippe Bouchard. Phil, sir.
Hello. Hey, Jose.
Hi, Philip, how you doing?
Good yourself. Great
Good.
presentation. By the way, I didn't understand everything, but I just want to say that I agree with you on the free energy. There's no free energy, although I use it sometimes. It's not really free energy capacitors, but it's kind of contradicts each other. But I just want to say I agree on that. And but do you have do you have like more in-depth theory on the how to get some energy out of nowhere in any way? Do you have like convert gravity into energy or anything like that?
Not yet. Okay, I am working on a device that generates electricity. I'm looking for funding to do that. Hopefully this presentation, you know, or I get some funding, not necessarily from you, but I can point other people to this presentation and they help me. And they believe me, at least, because I'm not the only crazy one that thinks that we can get energy out of this type of stuff. But I didn't present anything like that because I have investors already, so I am not gonna present anything. But yes, there is, I'm working on it. And about gravity, well, I'm trying to get this electric generator, and with that get funded to build, I wanna build my own UAP.
Yeah.
And yeah, later on, it's just the next step.
Yeah, investors are not easy to get for sure.
Yeah, we can do it together. That will be the best thing, actually. You know, we have great ideas, and if we actually agree on something, yeah, I'm sure we can build something.
Yeah, awesome. Well, great presentation again.
Thank you, Phil.
All right.
Yeah, wonderful. And Phil, thank you, sir. So again, questions are option Y on Mac or Alt Y on Windows. And Pepe, when you go to build your UAP, I have been doing interviews. That's my thing, right? That's my bent. And so I interviewed Gary Voorhees, who was on the Nimitz. We did that, I think, last Friday. And and then I interviewed Kevin Day as well, 3 or 4 days before that. And one of the things that Voorhees talked about was they had visual sightings from the Nimitz. So, you know, if you're into that, that's something that I think everything that's out there for these stories has been documented, but the media hasn't necessarily given it all the weight that it should have. And one of the things that I had heard, Kevin Day mentioned this. He said that, well, Voorhees took the binoculars down to the deck and he was basically sighting these things through the binocs while they were, you know, spotting them on a radar. So, so I got that. And then he also put me in touch with 2 other people from the Nimitz who supposedly have up close sightings. And I'm going to try and follow up with them. So the reason I mentioned that is my job, as it were, is to try and collect as much information for you guys to work with as possible. You know,
thank you. That's why I thank you, because I am getting a lot of this info.
Yeah, and a lot of it doesn't mean anything to me. You know, there are a lot of times where, like, again, this is just me. I'll somebody will tell me something, and I'll be like, this means something, but I won't know what. But then I'm wise enough now to realize that I don't need to know what, because you guys know. So it's just like, okay, give it to the people who know, you know. So they will change the world. Okay, so Mr. Sokol has his hand up. Sir?
Okay.
Hey, Pepe, thank you very much for that presentation. we were about to do some vapor deposition here at the lab for magnesium on top of the bismuth that we already deposited. And I just did a little safety check first to make sure that we have all the proper equipment in place, because magnesium could burn. It turns out we needed a special fire extinguisher for it, which is like, they go for like $1,500 for these Class D fire extinguishers. So we weren't able to, so I took that apart. We're not going to, fuck with that until I get the right equipment here in case there is a fire. The reason why we're doing vapor deposition is because in earlier tests, we found that there's an issue with the skin depth. EPR, which is the method we're using to create dynamic nuclear rotation, uses very high frequencies. And when you're dealing with a metal like aluminum, the skin depth at the gigahertz frequency is extremely thin. So you're only getting dynamic nuclear rotation on a very thin layer. So I'm trying to make many thin layers with a barrier in between them, so you get several different skin depths. Do you have any other ideas of how to get over the skin depth issue, or another way to create dynamic nuclear orientation?
Actually, I thought about it, but I haven't found, I don't have any ideas, but yes, I thought about it, but no, unfortunately, don't have anything yet. Yeah, but yeah.
We tried powders inside of epoxy, and those mostly just heated up. The best results we've seen were all with either sheets or just aluminum foil or just thin film. Everything thin film seemed to work the best. So that's what we're heading towards.
Well, another thing that I will try if I were you, just get some leaves, some natural leaves of trees, because they absorb a lot of those energies. That's natural things. You want to try and do an experiment and see what happens. That's what I would do.
Oh, any tree in particular?
No, just the one that has the bigger leaves. I guess it's easier.
Okay, yeah, we'll try that.
That's what I would do, because it's hard to find something like really works.
All right, thanks very much.
You're welcome. Thank you, Mark.
Awesome. Mark, thank you. Let me go to Michael Boyd. Sir?
So I'm just thinking about your presentation, Pepe, and so you know how in thinking about energy, when you go from a warmer temperature to a colder temperature, the substance will be in a lower energy state. And it will contract.
Yes, that's correct.
So I was trying to think of something that would be an example where that wouldn't be true. And what came to mind was water. When water goes from a liquid to a solid state, it expands in size. So how would your hypothesis explain that phenomena where basically the volume is increasing at a lower temperature? I would think it has something to do with the change in the atomic orientation or something like that, but I'm just curious your thoughts on that.
Okay.
Thank you.
Yeah, you're welcome. Yeah, well, first of all, about the temperature. Okay, how can you go from cold to heat, right? Is this your question first? Your first question?
Well, I'm going from a hot liquid to
Oh,
cold solid, but the area, the volume is increasing as opposed to decreasing.
yeah, actually, I know about that. Like, but I never thought about how my hypothesis will plug into that. I just thinking about that, but cool. I know it increases in size, and that's actually weird. I actually thought about that too. How will this idea well, the only thing I can think of is these lower energy density spots. They just kind of stay in one place or disappear somehow, and everything else Yeah, well.
Well, I was thinking
I'm
it
not
was
sure.
like the oxygen, there's like you got the two hydrogen atoms and then an oxygen atom, and the angle would change, like increase or decrease as a function of temperature, because you have basically you have two different elements here, and
Mhm.
they would have different properties, but it's also a dipole. That's the other thing to consider.
Um,
Something to think
I'll
about.
be, yeah, I'm gonna think about it because, you know, I know about that, when it freezes, it gets bigger, which doesn't make sense. I just go against, but I don't know why and how it will implement it with my hypothesis. I'll think about it and I'll get back to you.
Okay, thank you. I appreciate.
No, thank you. Thank you for listening.
Awesome. Okay, so let's go to Ross next. Ross? Sir?
Oh, hey, Pepe.
Hi, Ross.
So I kind of heard you when you first started, you're talking about like the wing analogy, how, you know, how the airflow goes faster over the top, you know, it's actually accelerating over the top, and then,
Mhm.
you know, it's going slower over the bottom, and it creates a lower pressure up the top, which makes the wing float. And you're kind of like a little baffled, like, well, how does it know to do that, you know? So you were talking about like energy differentials and things like that. It could also be thought of more as just like a very, very physical phenomenon as well. So a really good physicist told me that nothing can really move unless at the expense of its temperature. So as you know, wind is accelerating, it actually gets colder too. So that's another phenomenon. As it's going faster, it's actually lowering its pressure, and it's also lowering its temperature too. So if you could somehow measure, if you could stick in there like a probe and measure it, you'd actually see that the temperature of that airflow that's going faster is actually lower than the airflow underneath the wing, which is hotter underneath.
Yeah,
So
that makes sense.
it's not just a lower pressure, it's a lower temperature too. And the bottom has a higher pressure and a higher temperature as well. So just that's a fascinating thing as well. But as a physical phenomenon, this is sort of how I analogize it. So think about, you know, like you have a big trough with a bunch of cows, like animals, physical animals that are all randomly inside there. They're sort of like air molecules you can think of. So that's sort of like we're down here on the, you know, on the ground level, and we have what's called random, you know, air pressure. So all the air molecules are bumping into each other and everything. So they're confined. So think about the analogy of like a bunch of cows are all in a fence, and they're all locked together, and they're bumping to each other, and they're angry and bumping. And then you give them a vector, you open up a gate, and then all of a sudden they're allowed to go in the same direction. What it's called is a vector. So that's sort of like the wing analogy. They're given a vector. They're actually aligned now. So they're moving all in the same direction. So instead of bumping against each other and fighting each other, they're all in unison at that point. So they're all moving in the same direction. So then at that point, you have less pressure because they're not fighting each other. They're all doing the same thing. They're all going in a vector. So that's a that's a way that I have thought in my mind physically to kind of figure out what's going on with air molecules, is just to think of it in a physical analogy like that. So basically what's happening is the air molecules are all moving in the same direction. So they're basically in alignment, and they're not random. They're not bumping against each other. They're closely aligned. Everything is in unison. Everything's in harmony. They're all flowing in the same direction, really tight, nice and close to each other. So they're all flowing, and it's really cold because there's no bumping. The molecules aren't bumping, making heat. So that's why the temperature drops as well. The pressure drops, and then it goes faster. So that's what's happening, I think, on a wing, is that the air molecules are literally in alignment in a vector, which is decreasing the pressure, and then on the bottom, they're not going as fast. So that it's a higher pressure. There's a differential. So I just wanted to throw that out there. So that's a way of thinking about it.
Yeah, that's another way of thinking about it. Yeah, and about the temperature, yeah, I forgot about that, but actually that can also explain the lower energy density bubbles, the PEPs, okay? Because nature doesn't care where it gets the energy from to balance things out.
Mm.
And temperature could be one of them too. Okay, because what else can bring the temperature down? Okay, on the top of the wind and in the bottom, there's not much difference in altitude, so it's gotta be something else, and that could be the same PEPs. You know, it not only it pushes and pulls the molecules, it also brings the temperature down. So thank you for that analogy. I'm gonna use it too.
Okay.
Perfect. Okay, well, so let me see who else has questions against this. Option Y on Mac or Alt Y on Windows. Questions for Pepe? And if not, we'll give it a moment here and we can always go to our next presenter. Dun, dun, dun.
Mhm.
Well, it's okay to run a little bit ahead of schedule because we're going to try and squeeze Bill in too. So.
Yeah, exactly. Yeah, let's hear Bill. I'm interested in.
Okay,
hearing what
well,
he said.
yeah, so let's wrap up the Q&A session then. I do have one more person, Wayne Ojala, who is, where is Wayne? Wayne, are you with us? Wayne's not here. It's still early.